Hey everyone, welcome back. So where we left off was we were evaluating the integral of secant cubed, and we got down to this integral of secant cubed x was equal to secant x times tangent x minus this new integral of secant x times the quantity secant squared x minus 1, right? That was tangent, and we substituted secant squared x minus 1 for tangent. Okay, so, well, let's distribute this secant x and see what we'll get. We're going to get, let's see, equals, we still have secant x tangent x, okay, then minus, we have the integral of, well, secant x times secant squared x is going to be secant cubed x, right? And then we have secant x times a minus 1. So that's minus, we could split this up. Let's do that right now. We could, because we have, this is going to be minus the integral of secant cubed x, and then minus secant x. But we could split that into two integrals and say, okay, so we have minus the integral of secant cubed x dx, but then minus, well, minus a minus secant, right? Because here we have a minus secant times minus 1, so minus secant, but there's a minus in front, so it's going to be plus the integral of secant x dx, all right? So now we have another integral, but wait a minute. Take a look at this. We are solving for the integral of secant cubed x dx, right? And we got it equal to all this stuff. But then, look, right here. We have minus the integral of secant cubed x dx. Well, that's what we're solving for. And whenever this happens, whenever you have the integral, the same thing you're evaluating, appear right in the middle of the integral, what you can do is something really, really cool and pretty slick. You can pretty much use algebra to solve the integral without ever really solving the integral. So what do I mean about that? Well, take a look at this. Here you have minus 1 of the integral of secant cubed x dx, right? And this is basically an equation, right? Because on this side, you have the integral of secant cubed x dx. Well, if you add the integral of secant cubed x dx to this side, it's going to cancel, right? And if you do it to this side, well, now you're going to have two. You're going to have two of them. You're going to have two of these integrals, right? 2 times the integral of secant cubed x dx. Well, that is equal to what? It's equal to all this, to secant x tangent x. Well, now this is gone, right? We just added it to that side, so that's gone. But then we have plus, well, the integral of secant. Wait a minute, what's the integral of secant? Well, a couple of videos ago, I actually did the integral of secant, and if you get to this point, you could do it on some off to the side and figure out what this would be. But we actually already evaluated it, and it was actually the natural log of the absolute value of secant x plus tangent x. Okay? So that's this integral. So that we have evaluated. And now we're trying to solve for the integral of secant cubed, right? Well, here, right, we have 2 times the integral of secant cubed. If we divide by 2, or multiply by 1/2, right? If we divide by 2, what's going to happen? We're going to have the integral of secant cubed dx equal some stuff. Well, that's what we're trying to find. We're trying to find the integral of secant cubed x dx. So this is really cool. All we have to do here, we have this, is just divide by 2 or multiply by 1/2. Same thing, right? So we have the integral of secant cubed x dx is equal to what? It's equal to 1/2 times all this, times secant x tangent x plus the natural log of the absolute value of secant x plus tangent x, right? And then, of course, a plus c. And that's it. There's your answer. We just solved the integral of secant cubed x dx without really ever evaluating the integral. How cool is that? I think that's absolutely awesome, and I think I'm going to make one more video pretty soon where we look at the integral of secant to the 5th x dx. And this actually came up pretty recently on our Facebook page that we run, Math, an Integral Part of Happiness. And it was someone's work who actually did this problem. It was extremely neat, very pretty, but it looked extremely complicated and way more than it has to be. And I think we're going to look at this problem next, and stay tuned for that. So if you enjoyed this video, please like it, subscribe to the channel, and I'll see you all really soon. Thanks a lot. Bye.